Hi, I'm Brittany from Grasple. We understand that STEM questions are often complex, having several different variables and routes to a solution. On top of that, every student learns differently and at a different pace. While some grasp the material quickly and are ready to move on to the next topic, others may need additional support to help breaking down the problem into smaller, more manageable steps. With Grasple, you can accommodate the complexities of STEM questions and the needs of all your students by utilizing our conditional logic feature in your exercises. But what is conditional logic? Conditional logic questions are questions that react to the student's input to show unique next steps depending on their responses. We see two types of conditional logic questions on our platform: scaffolded questions and what we call choose your own adventure questions. Let's hop over to the Grasple platform to take a look at these two interesting use cases for conditional logic. Now that we're in the Grasple tool, let's take a look at the first kind of conditional logic question we see, the scaffolded question. Let's imagine I'm a student and I have a good understanding of linear equations. However, I'm a bit confused about what is meant by the b in y equals mx plus b. B, of course, being the y-intercept, where the line meets the y-axis. So if I was confused about that point of the linear equation, I might answer this question as y equals 0.5 x, which is the run. But again, I'm confused about the y-intercept, so let's imagine I confuse it with this one here at minus 6. So y equals 0.5x minus 6. And I'm given feedback showing that, oh, okay, I got this part of the question right, but I missed this term. The other nice thing is that I can actually see my line graphed against the actual correct line, so I can visualize where I may have gone wrong here. In addition, I'm shown follow-up questions to break down this concept. So, here we're given another graph. What kind of equation is shown on the graph? I know this is a linear equation. Great. I am also familiar with the form that linear equations follow, so I can answer this one correctly. Y equals mx plus b. Wonderful. Given that the linear equation follows this form, what is the m term? I know that the m term stands for slope, so that's great. And what is the b term? This is the thing I'm confused about. So I might say that this is the x-intercept. And if I check my answer, I see, it's incorrect. In fact, it's the y-intercept. Now that I understand that, and again, there's a description, the y-intercept represents where the line intersects with the y-axis. Now that I have an understanding of this, I can return to a graph. We're going to double check my understanding of slope. So what is the m term? I understand rise over run, so I can say that the slope is 2, right, which is the correct answer. And now I have an understanding of what the b term is. So if I go back up to the graph, where does the line intersect with the y-axis? Right here at minus 5. Great. Now let's put it all together using a different graph. So if I calculate rise over run, I see that we go up 4. So the equation is 4x. And then it connects at the y-intercept at minus 3. Or x minus 3. Check my answer, and that's correct. Now we've set this up as a straight path, where if I answer the sub-questions correctly or incorrectly, I'm still shown the same subsequent question. However, you can get very complex with conditional logic questions and have conditional logic even within the sub-questions, meaning that depending on if a student answers the sub-questions incorrectly or correctly, they can then be shown to a different branch. Now, if we reset the question, let's see what happens if the student answers the first question correctly. So we already said that the equation for this line is 0.5x, and the y-intercept is positive 3. Check my answer. This question is correct. Fantastic. In this case, I've completed the whole exercise. So because I've demonstrated that I've understood the concept, I don't then have to go through the comprehension checking questions. But why create scaffolded questions using conditional logic? Well, it allows you to create a personalized learning journey for your students, depending on the level of comprehension they demonstrate when completing an exercise. Think of it as branching paths. We still end up at the same place, we just took different routes to get there. Students who answer incorrectly will get extra support, while those who answer correctly move directly on to the next question. It's a fully scaffolded learning experience for those who need it. And it helps keep students motivated by giving them the right kinds of questions for their current level. They won't get stuck on questions that are too hard or bored with questions that are too easy. The second kind of conditional logic question that we see on our platform is this choose your own adventure type question. Here we see a STEM question which has multiple things that need to be solved. Conditional logic in this case is used to give the students the choice about which element of the problem they would like to solve first. Let's say that the first calculation that I want to do is related to this element here. So I can type B1 into the answer box. And great, I'm given a follow-up question that is related to this identified point in the problem. Now, this question is specifically about the point that I identified. So in one word, what can we say about the pressure at point A? I can tell you that we're dealing with atmospheric pressure here. Great. Now we have, again, a unique follow-up question. There's another point that has the same property as point A. Can I identify it? Okay. And I know that actually it is this point here on the opposite end of this tube. Memometer is the correct term, but
we can say DQ. Can I answer?
And correct. So we know that the pressure in A1 is atmospheric, as is the pressure in D2. And again, we have a unique follow-up question that responds to the first two answers that we gave. So after identifying the first two surface points A and C, we must find more points to apply this pressure formula. Where else are we going to see pressure? And we can see that there's actually two different liquids here, and they converge at point B3. So let's do B3. Great. And we've just identified point B, the point of the oil-water interface. And again, we have a unique follow-up question. We then need to find another area in this problem that has the same properties as point B. I know that it is the direct opposite point on the tube, so 3D is the correct answer here. T3. Great. We have now identified 2 points that have the same pressure. In one word, what can we say about the pressures at point B and B1? They are equal. And there we are. We have now completed this whole exercise. The interesting thing about the choose your own adventure type exercise is if I had, for example, chosen point B as my first point of interest, I would receive these questions in a different order. But why use conditional logic to create this kind of choose your own adventure question? Well, it allows students to start with what they know, and they can build up to more complex topics from there. It also helps break down complex STEM problems into steps that are easier to visualize and easier to tackle. And finally, students feel that they have control over their learning and can take ownership because they're the ones making decisions about where to start with a problem. And there you have it, a quick introduction to Grasple's conditional logic functionality. We hope you have a great understanding of the pedagogical possibilities of conditional logic and that you're ready to use them in your course. If you'd like to gain access to any of the materials that you've seen in today's video, please send us an email at hello@grasple.com. Thanks for watching and happy Graspling!